All right, this is the View Calculus class. We're doing topic 7, which is equations of tangent and normal lines. This is the second video in the series. In examples 2, 3, and 4, we have the same instructions for all of them. We're going to find the equations of both the tangent and the normal lines, which again is the same basic process. You just do one little thing at the end differently to find normal line. Okay, so to find the equation of any line, I need two things. The first thing I need is a point, okay? So I need a point. So I'm going to get that point by plugging in x is negative 2 into the original function, right? So I'm going to use f of negative 2. That's going to end up being a 10 divided by negative 2, which is totally a negative 5. So my point is negative 2, comma, negative 5. Great. The second thing I need is a slope, okay? Now, in order to find my tangent slope, I need f prime. There are two ways to find this derivative. The easier way is to treat this as a power rule, right? So if I treat this f of x as a 10x to the negative first, it's easy enough to derive and get that f prime of x is a negative 10x to the negative second, or a negative 10 on top of an x squared, right? Fine. The other way to do this, if you really hate that, is to do it as a quotient rule where your high function is 10 and your low function is x. It's going to come out exactly the same if you did it that way. Just to show you why, if you did it as a quotient rule, and I'm not suggesting, this is by far the better option, but if you did it as a quotient rule, right, your low would be x, so your f prime would be low, d high is a 0, minus high, which is 10, d low is a 1, draw the line, square the low, and you would still get negative 10 over x squared. It's the same answer. It's just easier not to do a quotient. So that's not my slope, right? My slope is going to be what happens when I evaluate negative 10 over x squared at x equals negative 2. So when I come up here, so I already have my point. I'm going to kind of come up to the top a little bit, right? Okay, so we're going to continue my quest for slope, right? So my tangent slope that I'm going to call m sub t is f prime at negative 2. That's going to be a negative 10 over a positive 4, or a negative 5 halves, right? So that gives me my answer right now for the equation of the tangent line, right? So my equation of the tangent line is y minus the y values, that's y minus a negative 5, so y plus 5, equals my m, which is negative 5 halves, x minus a negative 2, or x plus 2. So that's my tangent line. For my normal line, I recopy my own work, right? So for my normal line, I completely and totally recopy y plus 5 equals, I copy the x plus 2. The only thing I'm going to change is that the tangent and the normal line are perpendicular, so I use the opposite reciprocal slope, so I'm going to put a 2/5 instead of a negative 5 halves, okay? And that's it, right? So same task. Once you do the tangent line, it's pretty easy to jump right into doing the normal line. All right, let's do another one. Let's do example 3. So same task in example 3, except I give you a different function. This time it's trig. All right, so in example 3, f of x is 2 cosine of x, and we're doing this at x equals pi over 6, I think. Yes, okay. So to find the point, I need to do pi over 6, comma, and then this spot is going to be 2 cosine of pi over 6, right? Which is a 2 times a root 3 over 2, or just a root 3, right? And again, that does require that you know the unit circle pretty well, right? I also need a slope. So in order to find my slope, I need to find the derivative. Well, f prime of x is going to be a 2. Derivative of cosine is negative sine. So you can either do it as 2 negative sine x, or you could recognize what's happening and put the negative in front of the 2, right? So that means that my tangent slope is f prime at pi over 6, which would be negative 2 sine of pi over 6, which is a negative 2 times a 1/2, or a negative 1, right? So my tangent slope is a negative 1, right? And that means that my normal slope, well, let's go ahead and write the tangent answer first. So my answer for the tangent, my tangent equation is y minus the root 3 equals my m, which is negative 1, x minus a pi over 6. And you can see why it's not really fun at all to try and clean that up, because you've got roots and pi's and it's not pretty. In order to write my normal equation, I just need to flip the slope and change the sign, right? So y minus root 3 stays the same. I keep the x minus the pi over 6. When you flip a negative 1, if you flip a 1, you still get a 1. but you need to change the sign, so that's just going to be a 1. And you could get away with not writing that at all because it's a positive 1, right? But my normal slope, right, my normal slope is what happens if I flip this. So this guy was actually a negative 1 over 1. I flip it, it's now a 1 over 1, which is just a 1, okay? All right, let's do our example 4, and then after we're done with example 4, you can try your 4 practice problems. All right. Example 4, same idea, except our f of x is the square root of x, and we're doing this at x equals 9. So first thing I need is a point. That doesn't have anything to do with calculus, right? That's going to be 9, comma 3, right? I got that by doing the square root of 9, right? I then need the slope, right? So to find my slope, I need to find f prime. Sorry, wrong way. So my f of x is actually an x to the 1/2. So my f prime of x is a 1/2 x to the negative 1/2, or the easier way to see this is a 1 over 2 root x, because the negative 1/2 puts that root x on the bottom, right? So my tangent slope, mt, is f prime evaluated at 9, which would be 1 over 2 root 9, or 1/6, right? That means that my normal slope is going to be a negative 6 over 1, or just a negative 6. So when I write my two answers, my tangent equation is y minus 3 equals 1/6 times x minus 9. And my normal equation is y minus 3 equals negative 6 times x minus 9. And those are my two equations. Now, if you were taking this on like an AP Calc test, they would probably ask you for one, not both, so you have to be really careful and pay attention to which one they ask us for. But that's sort of the gist of this. So you're going to try practice problems 1 through 4 now.